So I'll start class with any questions that you may have. Number 50 from 1.2. 50. All right, so number 50, the question is, this is from 1.2, number 50. We're being asked, we're given u of t equals tan t over 1 plus tan t. Make sure you get your clicker when you come in. And you're asked to express this in the form f of g, right? F of g. So you need to rewrite this as a composition of two functions. Any suggestions here? G is the tangent of t. Let me go with that. G of t is tangent of t. And then what would the f function be? T over 1 plus t. Yes. That would be fine. So does this work? We're trying, f of g means you're plugging g into f, right? So if you take every one of these, if you take this right here, tangent, and you plug it into the f function, so replace that t with tangent, then this top would become what? Tan t, and the bottom right would become tan t, which would match up with this here. Yes? Good. 51. Okay, so 51. You're given capital R of x is the square root of x minus 1. And this time you're trying to break it into three functions, f of g of h. So let me try and do this one a little more constructive instead of just asking someone. I'm going to start working, let me see, maybe from the outside in. Like, what's my f function, then what's my g, and then what's my h. So the outermost thing I see that appears is a square root. So I'm going to say, like, the outer one is just the square root of x. What I'm referring to is this one right here, right? That's this guy right there. That's their square root function. Inside of that, I have a square root of x minus 1. I'm going to look at that as being something minus 1. Instead of square root of x minus 1, just being something x minus 1. So what I'm taking care of here is this whole thing down here, but instead of x, square root of x, I'm just calling that piece on the left side x. And that would force my h function to be what then? The square root of x. So let's see if that got plugged in right there. I know this kind of looks weird, but let's just try it. This pink goes in here and becomes square root of x minus 1. That whole thing gets plugged in here, and you have the square root of x minus 1. So that should work. Sometimes there's more than one way to do these. Sometimes there's not a unique representation that you can approach it different ways. But this one looks like that's the most natural. Anything else? Let's take attendance real quick. Okay. Which one on 37? Part A, B, C, D? Did you check the back? Check the back? Yeah, I would check that. That one's just too much college algebra. It would take me 10 minutes to go through that. Okay, everyone's got their clicker. You're here? Yes? Okay. All right, let's start with our quiz. So please clear your stuff off the desk. All right, so look, on this quiz, if you're sitting at a table where y'all are like this, just like turn and go to the computer tables behind you, just so there's not any issue. Yeah, if you don't, I mean, just because you're kind of crammed at the end, you're fine there. Y'all are okay there. All right, so here's the deal. I'm going to give this to you face down. Everyone's going to have exactly 7 minutes to finish this. Part of what you're tested on here is not only your understanding, but the speed at which you can understand. All right? Because on a test, you won't have that up. You're going to have to do a lot of problems in a short amount of time, so we need to get used to being prepared. You can start when I say go, but just not yet. Wait till everyone's trying to see through their paper backwards there. I'm going to give everyone the same amount of time. So just hang tight. 7 minutes. There's 3 problems, but a lot of them are visual. Well, one of them's visual. 7 minutes doesn't seem like a lot of time, but it is. That's right. It's greater than 0, less than infinity. Everybody have a quiz in front of them? And go. Make sure you put your name. When you're done, turn it in, okay? Bring it up here. Can you go pick up your old quiz and then your bonuses on the end? Make sure you get your clicker if you haven't. If you haven't got your clicker, make sure you get it. So we'll start with a quick poll. Okay, so how many of you felt like that went okay for you? Whoa. Interesting. Okay. I'll post the solutions. I'll post the key for this online, right, later today. So that way you'll be able to go through and look through it, see if you can make sense out of it, and then if you have questions after that, please feel free to ask. I'm not going to go through the quiz right now. All right, so we finished up last time talking about the limit, right? This idea of looking at a function and trying to approach an x value, walking along the function from the left and from the right, yes? And if you watched the video, which you were supposed to do, then we have this concept of left-sided limit and right-sided limit, yes? And we have different notation for that left-sided limit and right-sided limit. Right, this was the notation for the limit. This is what we use right here. And where was the left side? Right side, did I do that up here? One direction, okay, so we'll get to that one direction. I almost got sick just in this now. So we're gonna focus the beginning of this class sticking with the idea of looking at the pictures of functions and trying to identify limits. After that, we get into looking at the algebraic function, no picture, and seeing if we can figure out the limits, which will be the harder of the two, right? The second part. So let's start off with this example right here. All right, it says, I would like for us to sketch an example of a function with the following properties. All right, so make sure we can all see this. All right, so these are the properties we want our function to have. This says the limit as x approaches -2 of the function is equal to 3. Then we want f of -2 to be 0. Let's just start with that, all right? And then we'll go on to the other things. So I'll jot these down on another sheet for us. We want the limit as x approaches -2 of our function to be equal to what? What was it? 3? 3. Okay, let's just see visually what that means. It means we have a function. It means that, well, I should draw it this way. It means that if we go to -2 on the x-axis, right, and we imagine that there is like a vertical line, this is not part of our graph, that on this function, as we approach -2 from which side? It doesn't say, right? It doesn't have a little plus or a minus to the top right. If it does not have a plus or minus, it means both sides. So it's saying that when we approach from the left and from the right, we have to be headed towards what? 3. That means a height. The height of our function needs to be headed towards 3. So I'm going to go label 3 on my y-axis. And it doesn't matter how I draw it. Let's see, 3, I'm going to draw a circle, an open hole right there, okay? I don't know what's happening at -2 right now. What I know is that as I get close to -2 from both sides, I need to be getting closer to that value. So I could be doing something like that, and perhaps I could be doing something like this out the other side. Doesn't really matter what I'm doing, as long as from the left and from the right, I'm headed towards 3. Does that make sense? All right, the other piece of information, I don't like that. I'm going to do mine like this instead. There. Okay. The other piece of information is that f of -2 has to be 0. So in my drawing, at exactly the value -2, right, it needs to be 0, which is the same as an x-intercept, isn't it? So the y value is 0 means I'm down here, and I'm putting a solid dot there. So if you were walking along this function, as you come into -2 from the left side, you're approaching 3. As you come in from the right side, you're approaching 3. But when you actually get to -2, you're down here at 0. Yes? So limit approaches a number. The function's value at there is not a limit. Make sense? Some people have talked about calculus as being, let me move this down so I can get to it. I can't quite get to it. Some people have said calculus is like taking, get my little visual, not calculus, but the limit idea. is like, imagine in college algebra, what we do is we say, let's look at the function's value at a specific place. So we go and I say, what's happening at -2? I cover up everything except -2, right? And I say, what's the function here at -2? And what would you tell me? What's the function at -2? 0. You don't care about anything else, right? But in calculus, the limit, what we do is this. We actually open up these windows and we cover up the middle. And we say, what's happening on each side of that? Does that make sense? So that's what our limit is, a study of what's happening near a value, not at the value. So would this satisfy the first two conditions of our function? Would that satisfy those two? Yes, but I need my function to satisfy all of these conditions. So let's just keep going through these. I need the limit as x approaches 1. What does this thing here, the negative up there, mean? From the left. That means as I draw my function, as I'm getting closer to 1 from the left, I need it to be headed where? -1. But as I approach 1 from the right, I need to be headed towards +2. So I'll write all these out, and I'm going to do a separate graph. I'm just going to write these out. X approaches 1 from the right of my function had to be -1. But then you wanted the limit as x approaches 1 from the right, my function to be 2. And also, I wanted f of 1 to be what? What does it say here? F of 1, I need it to be 2. Okay, let's see if I can make all that happen on a graph. So I'm interested in which x value? Where am I approaching? 1. So I'm going to label 1 here on my graph. I imagine that there's some, vertical imaginary line here. When I'm approaching that value from the left side, the negative means from the left, I need to be headed towards what y value? -1. So I'm going to show where -1 is over here. So when I draw this, I'll do it in blue, I need to be headed towards this open circle right here from the left. Why am I leaving it as an open circle? Because I don't care what's happening at -1, at +1. I don't care. The limit from the left being equal to -1 means as I get closer to that point, I'm getting closer to a y value of -1. Do y'all see that? What about the next limit? This says from the right side, I need to be headed towards 2, y value of 2. So I need to be up above the x-axis. 1, 2. I'll draw it in blue again. Here's a little hole. I'm coming in from the right. Would that be okay? That would be fine? Okay. What's happening at 1? My value of my function is 2. So what does that mean I can do to my picture here? At 1, I need to be up here at 2. So what should I do with this little hole? Fill it in. Let's vote. Maybe. There it is. How many of you are okay with this? Yes, thumbs up, no, thumbs down. Or just ask a question, yes. It's all supposed to be one graph. I'm doing each piece one at a time, and we're going to put it all together at the end. Okay, I just thought I'd take a little slower by doing each kind of idea one at a time. Okay? Let's see where the next interesting thing is happening. I need to know, or I need to show that when we approach 4 from which side? The left. Why does the minus sign mean left? Think of the axis, x-axis, right? Negatives are over there to the left, positives to the right. Just think of it that way. So when you see the negative side and you're approaching from the left side, positive coming from the right. So I need that as I approach 4 from the left, my function needs to go to positive infinity. But when I approach 4 from the right, I need to be approaching 0. And then at 4, my function is undefined. So let's see if I can put those three pieces of information together on a picture. I need the limit as x approaches 4 from the left of my function to be headed to infinity. I need the limit as x approaches 4 from the right of my function to be headed to 0. Okay, thank you. And then f of 4 was undefined. So here we go. 4 is out here somewhere. I like to put this imaginary sort of line through this. You don't have to. It just maybe helps you see where your function has to eventually go to here. From the left side of 4, I need to be headed to positive infinity, which means it's acting like a vertical asymptote. It's forcing my function up forever. So I'm just going to be like, okay, I'm trying to get closer to 4. Nope, can't do it. I got to go up to a positive infinity. Just put a little arrow on it. It's understood that that's just going to take off asymptotically. You could also put dashes here like this, dotted line, to represent that vertical asymptote. Okay? Does everyone understand that what's happening here to the left of this, I don't care about? I'm just trying to take care of what's happening near 4. I'm going to paste all these pictures that we've done together into one final answer here. To the right, let's see, we're coming in from the right and we're approaching 4 and we are headed towards where? 0. So that means a height of 0. I put an open circle here. Doesn't matter how I approach it. Could I do this? Sure. It can be linear. It can, it can look like a line. It can squiggle on its way in. Doesn't matter. As long as I'm getting closer to 4 from the right, my function's getting closer to 0. And then what about f of 4 being undefined? Yeah, that means I'm going to leave this circle open. And in fact, I'm never going to fill a dot in anywhere. So if someone were to say, hey, what's the function's value at 4? You'd be like, it's not defined at 4. You cannot plug 4 in. All right? So let's now put it all together in one picture. The first piece of information we had was this picture right here, right? That's what's happening at -2. Then you have what's happening at 1, right? And then you have what's happening at 4. So -2, 1, and 4 where the interesting things are going on. -2's here, 1's here, let's just say 4's out here. I'll do the 4 one because it's the one that's freshest in my mind right now. It went up like this. This side it came in like this. And it was undefined there. So that's what I have. Right? That's what was happening at 4. At 1, from the left it went to -1. From the right it went to 2. So here's -1, 2 on my y-axis. So from the left it was what? -1? From the right it was 2. What was the function's value at 1? 2, so we filled in that dot right there. And then let's go to the first one we did, which was -2. 3 from the left and right, and then 0. 3 from the left and right, and then 0. So, whoa, don't do that. 3's up here, so 3 from the left and right, and then 0. All right, let's quick poll here. Are we okay with that so far? Right. So the last thing I want to do is I want to make this a function. So I want to connect these all together and just make sure that when I draw it, it passes the vertical line test. So it does. This is where we can all have different pictures, you know. It's nice and smooth. Connect those together. You know, I can do anything I want over here. I can make this one come back down. Over here, I can make this one flatten out. It really doesn't matter as long as it's a function. See how I connected those all together? We have a function that satisfies all of those conditions. You'll definitely have something like that on a test where I give you all the conditions and you draw it out. All right? We good? Okay. All right, so if somebody gives you conditions, you should be able to draw a function doing that. If somebody gives you a picture, you should be able to come up with the conditions. So the other way around. Would you all like to do one of those, where I give you a picture and then we come up with the conditions? Yes? All right. So what I'll do, I had this in mind that we might do this. What was it, fall 2014? This was, and I'm not trying to hide this from you, this was exactly a problem off my first exam for my Cal 1 class last semester. Okay, so there's the graph of the function, and what we're supposed to do is come up with the following limits. All right, so I'll go through these one by one with you. All right, the first thing we want to know, by looking at this, you can tell that we're interested first in looking at what x value. -1 first, and then we'll look at what's happening at x is what? 0, then we'll look at 2, and then we'll be looking at x is infinity. Okay, we'll get back to that. And then x here is 3, right? Let's start with x is -1. Come down here, look at x is -1. It's this, right? Tell me what's happening as you approach -1 from the left. Where's your function headed? So from the left, we're headed up towards a y value of 1. So the answer to that one would be 1. Equals 1. Okay, if we are approaching 1 from the right, -1, sorry, from the right, we're headed towards what? Y value of -2. So what's the limit as you approach -1 if I don't tell you left or right? Well, from the left, what is it? From the right, what is it? Okay, for the limit to exist, it has to be the same from both sides. So this notation right here, the fact that they do not give you a plus or a minus there means that if there is an answer, it needs to be the same from both sides, the same number, which it's not in this case, right? So what we would say here is does not exist. We say the limit does not exist. Or we write just D, N, E, does not exist. We do not put undefined. Undefined means the function's not defined somewhere. Does not exist means is what we reserve for limits. If you can't figure out what the limit is, we say the limit doesn't exist. Are there any questions on that? Left and right have to be the same for that to be okay? Yes. If you have a jump like this, see that break in the graph, you're always going to have a does not. The limit will not exist there. Now, let's be clear. The left limit exists. From the left, it's 1. So the left-handed limit exists. The right-handed limit is what? -2. But the limit does not. That kind of seems weird. The limit just by itself is a stronger condition because it requires both left and right to be equal. Yes? If the limit does exist there, I believe one of these is going to do that. Yeah. Look. Yep. That's what this next one is addressing. See, look at this. What's the limit as x approaches 0? Well, that means I have to look from the left and the right. Yes? Because it doesn't say anything up here, left or right. So I look at 0. Where's 0 on my graph? I'll do it in green. X value of 0 is here. Let's approach this green. I don't know if you could see that. From the left, where are we headed? -1. Where are we headed from the right? -1. Are they headed to the same place? Yes. At that point, that limit is what? -1? Does it matter that this is solid in here? It does not matter. Okay? This could have a hole in it, and the limit would still be -1. Yes? Where do we get the -1? Right here? I'm not sure which one you're... Where did we get this from? Oh, no, this whole graph was given to us. Everything in blue here that's sitting there on the test, and you got the picture. Now you have to go back up. You have to answer all those questions based on that picture. Yes? All right, what's happening as x approaches 2 from the left and 2 from the right, and then what's the function's value at 2? So where's 2? I'll do it in pink. What's happening as we approach 2 from the left? We're headed down, 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 -infinity, right? -infinity. What about 2 from the right? So it looks like it's oscillating, right? But then it eventually goes up and comes back down and looks like it's getting closer and closer to a y value of 2. So that would be okay, too. And then what about f of 2? 0, because at 2 we have a solid dot down here at a y value of 0. What happens as x goes to, you know what? This was supposed to be -infinity. Let me change this. -infinity. What does this mean? What do you think that means? How is the function behaving as your x values go where? Where's -infinity? On the x-axis, where is it? To the left, right? And -infinity means to the left forever. So it's saying, is your function doing something as you go out to the left forever? It looks like it's approaching 0, right? As we go down like this, out to the side, the further we go, because this dotted line, it's representative of a horizontal asymptote, and it looks like my function is getting smaller and smaller and smaller, approaching 0. Does it ever get there? No, but I never get to infinity anyway, so it doesn't matter, right? I'm approaching 0. So this would be 0. That's what my function's doing. Last one. What's the limit as x approaches 3 from the left? Okay, so here's 3. Right? All my students had trouble with this problem because it was hard for me to draw what I wanted it to do. What does it look like the function is doing there? Does it look like it's headed somewhere? It's supposed to be oscillating back and forth. I showed you an example last class, a function that's getting crazy. And so what's happening here is you can't figure out if it's headed towards any one place from the picture because it looks like it's just jumping up and down forever. So what happens if you can't figure out what the limit is, or if it has a jump like that? What did we use for that? Does not exist. All right? So that's what we'll put here. Does not exist. And what I will do is I will grab this page and I will paste it into today's notes so that you can go back and reference that. Maybe not. There we go. Okay, so that is now in here, okay, for you to look at. By the way, I believe the exams are online. My old exams are all there. You can go look at them. Questions on this? Let's take a poll. Are we okay with that or not? Good. All right, so I give you conditions, you draw it. I give you drawing, you give me the answers to the conditions, right? Now we go into how do we approach finding a limit of a function without the picture. So we are now in 1.4, which I asked you again to look at the notes for. So there were a bunch of laws, right? Limit laws in these notes. We're going to use these throughout today, but I'll just do a quick summary. When you're doing limits, if you have addition or subtraction between two things, two terms, you can just look at the limit of each one individually. That's a good thing. If you have a constant in front of a function, you can ignore the constant and just take the limit of the function. If you have a product, two things being multiplied, you're trying to figure out what the limit is, you can take the limit of each one and then whatever those answers are, multiply them. Quotients work the same way. The limit of something to a power, you can ignore the power, take the limit of the function, figure out what the answer is, and then raise it to the power. You'll see all these as we work through them, okay? But we have to state them because you cannot assume that it works this way. So we're given this. The limit of a constant is the constant. That one's kind of a strange one, but I'll show you with the picture in a minute. So those 11 limit laws, just know they're there. We'll refer back to them. Direct substitution property. This is a nice little result. All right, remember how when you have functions have domains, like what can be plugged in, what can't? All functions, if you try and plug a number into the function, and that number is, your function is defined there, then the limit is just what you get when you plug that number in. There's no problems. The only time the limit becomes interesting is if you try and plug a number in that doesn't live in the domain of the function. Here's an example. Look at this right here. F of x equals square root of x over x minus 4. If I plug any number into that other than 4, then the limit is going to be whatever that is when I directly substitute that value in. So like, let's plug in 1. What would the limit be as I approach 1 on this function? Well, what's the square root of 1? 1. What's 1 minus 4? Negative 3. So 1 over negative 3 would be negative 1/3, and that's the answer. Whoop-de-doo. You just plug in the number. Direct substitution says if the number you're plugging in lives in the domain of the function's defined there, that's your answer. There's nothing spectacular to worry about. It's only interesting when we try and plug numbers in that don't belong in the domain. Like, what number here? 4. What's happening as this function approaches 4? Can anybody tell me? That's what f of 4 would be. What's the function approaching, though? Or is it not even approaching anything? What was that? Square root of x over x minus 4? We're just going to take a look at this real quick. Oh, I forgot. Got my bracket. Okay, there is the graph of that function, all right? Now, this vertical line right here is the computer's like inability to handle what's happening at 4. The computer is like, I have no idea what to do because my function goes and it goes like this, and then all of a sudden after 4 it's up here. So what does it do? It draws a line straight up trying to connect the 2 points. So this is a limitation of the computer. Imagine this is not here. Now let me ask you this question. What's the limit as you approach 4 of this function? Well, from the left, what is it? From the right, what is it? So what's the limit if from the left and the right aren't the same? Does not exist. But see, the left limit does, and the right limit does, but the fact they're not the same, it does not exist. How do we know that without this picture? That's what we're going to be doing, all right? But keep in mind, the direct substitution rule says as long as the number you're plugging in behaves well in there, there's nothing to worry about. It's just whatever you get out when you plug it in. All right, so let me work through some of these problems. It is time to unleash the Kraken. Is it the Kraken? Do some problems on page 44. So let's take a look at this first example. I would like you to tell me, if possible, what the limit as x approaches 3. Now, I'm not doing the evens out here. I'm just kind of making these up as I go, okay? Because I've already done these evens too many times. How about x plus 7 over x plus 3? So what we want to imagine we have here is this right here is our function, all right? This is the function f of x. And I'm asking, what is that function doing as I get close to what? 3. So what we first try to do is the direct substitution. Can you just plug 3 in and get a number out? If so, that's your answer. So try plugging 3 in, and what do you get? Limit x approaches 3. Oh, you know what? Hold on. You get on top what? 11, so 3 plus 7. And on the bottom, okay, it's all right. 3 plus 3. So you get 10 over 6, which is 5/3. And that is a number, right? This is using the direct substitution property. We said, hey, what's happening in this function as I approach 3? Oh, well, let me just try and plug 3 in. I get a number over a number. I'm happy, okay? I have something on the board here that we're going to refer to throughout the rest of today. What we just had right now in this problem isn't even on this board. What we just got right now is a number divided by a number, didn't we? That's the simplest case possible. In fact, so simple it probably will never appear on a test, okay? But we need to keep in mind that that's always the first thing you want to do, is try to plug the number in, see if you get a number over number. All right, so let me tweak it. Let's do something like this. What's the limit? How about x approaches 3 of x squared minus 3x over x squared plus 1. So what I do first is what? Just try to plug 3 in. So I'm going to see what happens. This equals, let me just plug 3 in. What do I get on the top there? 9 minus 9 over the bottom. 9 plus 1, so this is 0 over 10. What's 0 over 10? 0. Okay? That's no problems there, right? No issue at all? That's all okay? So we don't have anything going on there. I want to also point out, notice the limit here is here and then it's gone, right? Why is it gone? Because I actually let x go to 3. Same thing up here. The limit was here. I say equals. Now the limit's gone because I let x approach 3. This problem right here is exactly what we just got here it's a number over a number, isn't it? It's a number over number, but specifically we got 0 over number. Anytime we get 0 over a number like that, that should equal 0, shouldn't it? Okay. So far, this is not calculus, right? This is just plugging numbers into something and nothing interesting. Limit x approaches 3, square root x minus 3 over, oh, you know what? Let me change that, sorry. Square root of x minus square root of 9 over x squared minus 9. Now we have calculus. Because what happens, change, sorry. This one right here, change that to a 3. I want that to be a root 3, not a root 9. Of course, square root of 3 was 9. Square root of 9 would have been 3. So, is that okay? All right, what happens if you plug 3 in here? On top you get, and watch, I'm going to do this with an arrow because I know it's going to cause a problem here. I get square root of 3 minus square root of 3 over, 9 minus 9? So I get 0 over 0, don't I? And that is why we're here, all right? Because when you get 0 over 0 in a limit like this, we don't know what the answer is, okay? We do not say undefined. We don't say does not exist. We say that's why we're here. So let me show you a graph of this first. I'm going to show you this graph just to convince you that there is something happening, all right? So it was plot. It's a little faster. So what was my function? It was square root of 3, or square root of x minus square root of 3 over x squared minus 9. And where are we interested in? What's happening at 3? I don't know about you, but it looks like as I approach 3 from both sides, I'm headed somewhere, right? The same place from both sides? Do y'all see that? I need to be able to figure out what that value is without that graph. Understand? Now, also, what happens if I try and plug 3 into this function? If I just plug 3 in, it is undefined, right? Which means that there is a hole here, which is not, the computer does not show you a hole. Same with your graphing calculators. They don't show holes. So you think it's a nice smooth curve when there is actually a hole in there. So you're missing that piece of information on here. Do you all understand that? But we are still going to try and find out what's happening as we approach from left to right. All right, so this right here, anytime from now on, if we take a limit, and if we get 0 over 0, this is bad. Bad situation. I don't know, it depends on how you look at it. It's good if you like this. It's bad if you don't like it, but it's bad in the sense that we've got to do something, okay? We can't just leave it. It's not just, oh, here's the answer, 0, or undefined. In the limit, what's happening? So this is where the algebra comes in, all right? Calculus 1 is a lot of algebra on steroids. What we're trying to do is make the division by 0 go away. That's what our goal is. That's what's causing this thing to suck, right? If we had 0 over a number, the answer would be 0. It's the fact that we have 0 over 0. So how can we make that 0 go away on the bottom? Well, the only way to make it go away is to figure out what's causing it to be 0 down here. So does anyone recognize x squared minus 9 as something from college algebra? Or before that, difference of squares? It would be what? X plus 3, x minus 3? That's your difference of squares. This is the part that's causing the problem, isn't it? The only way that I can make that go away is if I can somehow maybe cancel it with something on top. And what I mean is I have to cancel it with an x minus 3 on top. But do I have an x minus 3 on top? No. So I'm going to do something a little more clever. I'm going to force you to look at something here. Let's look at that x minus 3 on the bottom. Everyone hopefully just remember the difference of squares formula, right? If you have something squared minus something squared, you can always turn into that thing, right? What about this? Is this a difference of squares? Depends on how you look at it. I argue that that's the same as the square root of x squared minus the square root of 3 squared. Now, you would never want to do that because it looks more complicated than it started as, right? But do you agree that if you take the square root of x and square it, you get x? Do you agree that if you take the square root of 3 and square it, you get 3? So don't you really have now like a squared minus b squared? So you could factor that as what? Square root of x plus root 3, square root of x minus square root of 3. You could do that. Check it. FOIL this out. What's root x times root x? X. What's root x times negative 3 root, or root negative 3? Well, it's whatever it is, right? But look at what's going to happen in the middle. They cancel each other out. And then what's my last term? Negative root 9, which is negative 3, which is this. And, yeah, so you see if I take this yellow and I break it down to these two, it will cancel the top. Okay, now look, this is why we're here. If you've never seen that, I'm here to show you that. Now that's fair game. So when you see something like this and you see something like this, you're thinking automatically, this could be looked at as a difference of squares. And you see that up there, and then it would cancel. But you have to be able to like extrapolate that from the problem, which is not a very natural thing to want to do. Right? So let's rewrite the problem. I'm going to bring this up here, down here now. That red was just my work. So we have limit, x approaches 3. We had root x minus root 3 over, it was x plus 3, but then that thing in yellow turns into root x plus root 3, root x minus root 3. And now these factors cancel. I forgot my root around this one. There we go. So I'm not letting x approach 3 yet, right? I did some algebra, some weird algebra, and then I canceled this stuff, and now I have a new expression, don't I? My new expression is limit x approaches 3. What's on top? 1. And on the bottom is x plus 3 times root x plus root 3. Now please let x approach 3. Let x go to 3 now. What would you get on top? Just the 1, right? On the bottom, you're doing 3 plus 3, right? 6 times, what is in this parentheses? Root 3, right? Because this x is being replaced with 3. Root 3 plus root 3 is 2 root 3s. So this is really just 1 over 12 root 3, which we could rationalize the denominator. Anybody have a calculator? Figure out what that is real quick. I mean, get it as a decimal. I don't think I brought mine. 1 divided by 12 root 3. .04811, something like that. So what I'll do is I'll go back to my picture here. And where were we approaching? 3? I don't know. .048 you got? Let me see that real quick. It's just I'm not convinced with my picture that that looks right. See what I'm saying? Like here's 3, go up. Does that look lower than .05? I can't tell. From what I see here, it doesn't look right, but up here it does. It's weird. If I go over, right, it looks like slightly below .05, doesn't it? 0.08 or 0.048. So, yeah. Well, on mine it looks all weird. It's kind of all right. Are you convinced that we got the answer? Y'all are okay? Let's take a vote here to see how y'all did with that, because I can't tell if y'all are okay. So go ahead and vote on whether or not that was okay. I'm not asking, like, would you have done that difference of squares? I'm saying after I showed you, are you okay following that algebra? Okay, let's try something else. Try a different problem. How about limit x approaches -1 of x squared minus 4x over x squared minus 3x minus 4. What we always do first is just try and plug in the value and see what we get. And I always like to do that by drawing a little arrow out here and just writing down what I'm getting. If it happens to turn into a number over a number, we're going to be done, right? Let's see. Plug -1 in. What do we get up top? 1 plus 4, which is 5. On the bottom, 1 plus 3 minus 4, which is 0. Yes? Something like that? Make sure I got this down right. So we have a situation here we haven't had yet, right? We had 0 over 0, and we just realized we had to do some algebra on that, didn't we? Yes? And we had a number over number that was easy. 0 over number was 0. What we have now is a number over 0, this one. And the question is, what is happening there? Why don't we take a look at the graph? I'm telling you we're not allowed to take a look at the graph, but I'm in the teaching format. I want you to see the graph to see if maybe there is an answer. So it was x squared minus 4x over x squared minus 3x minus 4. There's my graph. Here's -1. Uh-oh. The limit does not exist, right? The limit does not exist. So look, for now, and it's only for a short period of time, not until next class, for now, when we have this scenario, only for now, we're going to say does not exist. We will have a way of figuring out that it was infinity from one side and negative infinity from the other, but not till next class, right? So for that one, does not exist. I'll summarize all this. I'll put it in your notes, okay? So when I put these out on the web, you'll have a way of referring back to this. All right, so our answer here is does not exist. Does not exist. Does. That's a D, okay? I had a calculus class once where went through almost the entire semester, and then this girl came up to me towards the end of the semester, and she goes, one thing I've been wanting to know is why do you always write 1 at the end of, and I'm like, oh, oops, that does not exist. So she thought that was 1. I don't know. So that's a D, D-N-E. So limit, let's do another one. That one was kind of blah. How about this one? Limit h goes to 0. 2 plus h cubed minus 8 over h. What's happening here? If h goes to 0, right? If we let h go to 0, become nothing, you get what? 2 cubed, 8, minus 8, 0 on top, and on the bottom, if you let h become 0, you get 0. So what we have here is the 0 over 0, the one in the green box here. And this is the one that I said when you see that, it is bad situation. That means we got to break out the algebra now. We've got to figure out if there's a way algebraically to figure out what's happening here. We'll take a look at the graph after we do it, okay? Any instinct here? What do you want to do? There's several options, so that's why I'm letting you dictate. You want to expand that out? Like you want to do 2 plus h times 2 plus h times 2 plus h? Is that what you're saying or no? You want to use this as a difference of cubes? You can do that. But you could also multiply 2 plus h times 2 plus h times 2 plus h. So let's take a vote. How many of you would like to do 2 plus h times 2 plus h times 2 plus h? Say yes. If you want to do difference of cubes, say no. Let me vote then. 50-50, great. All right, well, I'll do both. I'll do both. Okay, so let me do the 2 plus h cubed first. On the side, 2 plus h cubed. Now, I'm teaching Math 1414 this semester. Did anybody have to take 1414 math here? Okay, here, 1414. Okay, good. This is something I would do in 1414 day 1, like expectation. So I'm not going to multiply this out. I'm just going to show you what the answer would be. If you have trouble multiplying this out, please just come talk to me or go to a tutor or something. It's 8 plus, let's see, does anybody know? Does anyone know the shortcut for it? I don't know if I want to get into that or not. This is a Cal 1 class, so we could get into the shortcut. Six h plus 6h squared plus h cubed. We won't do it right now. We'll do it later. That's what you would get. We should get if you multiply this all out. One of these, hold on, 12. Sorry, 12h. Now, while we're talking about this, I'll bring up something that you probably know of. Y'all have heard of Wolfram Alpha? Website, go search it. If you're not aware of this, it's a great tool. It's free. You go here. If you wanted to know what 2 plus h cubed was, wow, it's right here. Just hit enter. It should have the expansion here, right there. Oh, I covered it up. Where'd it go? There it is. There's the expanded form right there. So it multiplied it out for you. It's just a way you can check your work. I definitely do not say, rely on this for your algebra. But if you want to check it, you can. Wolfram Alpha is awesome. Used to not be there when I was a student. Wasn't there. So look, we have this is our expansion of this, right? And then I have minus 8. So let me just write that all down. I have 8 plus 12h plus 6h squared plus h cubed, but then I have minus 8. All of this over h. And what happens here? Do y'all see what happens up on top? The 8's cancel. Right? 8 minus 8, 0. And so everything that's left has something in it in common. They all have an h. And again, if you took 1414, you recognize maybe you did this like difference quotients, you got this thing to happen, and so that's what's happening here. We're going to factor an h out of the top and cancel it. And when we do that, we're left with an expression, what, 12 plus 6h plus h squared. So I pulled an h out of the top, out of every term, and cancel it with the h on the bottom. Also notice I've carried this symbol, this notation down with me the whole time. Limit h goes to 0. Limit h goes to 0. I'm carrying it with me because have I let h go to 0? Not yet. It can go away only when you let h go to 0. This is something I will grade you on. If I give you a quiz and you just write this down, and then you write this down without the limit, and you write this down without the limit, and you write this down without the limit, and then maybe towards the end you put the limit, and then you give me an answer, you'll get counted some points off. Proper notation. Start with the limit. It's a limit, it's a limit, it's a limit, it's a limit. Now let h go to 0. So what happens if h becomes 0 here? Those go away, right? Those vanish to 0, and all you're left with is 12. So this means if I were to graph that function, right? If I were to graph it, if I look at the function as I approach 0, it should be headed towards what? 12 from both sides. I'm still going to do it the other way because you asked me to, but I do want to graph this. It was 2 plus h cubed minus 8 over h, yes? There's the graph. Do you see what's happening at 0? Where am I? Up here at 12. Couldn't tell that unless you had the picture or you did the algebra to get it, right? So here's the other way. The other approach, I'll just start a new page. Limit h goes to 0, 2 plus h cubed minus 8 over h. What I would need to use is this. If you have a cubed minus b cubed, this is a minus b times a squared plus ab plus b squared. That's your difference of cubes formula. And in this problem, what would a be? What's our a? What's the thing being cubed? 2 plus h. What's the b for us in this? the 8, but actually the b would be what? This is 2 cubed. So the b would actually not be 8. It would be what? It would be the 2. You would have to look at that expression up there as being something cubed minus something cubed. The first part of it would be the 2 plus h. The second part of it would be the 2 and then cubed. I think this is the harder way personally, but it was 50-50, so I'm showing it to you. So how could I rewrite the top then? According to this right here. It would be the a. What's a again for me? 2 plus h. And then I take away b. But what's b? 2. So take away 2. And then I have the rest of it. What's a squared? Well, 2 plus h squared. I'll just write it there. 2 plus h squared plus, what's a times b? 2 times 2 plus h. And then what's b squared? B was 2, so 2 squared is 4. And then all of this divided by what? H. What the hell happens here? These 2's go away, which leaves an h here and an h here, which then cancel each other out. And now you should not get the division by 0 anymore. So let h go to 0, and what would you get? This would be 2 squared 4. This would be, what, 2? So 4 here, and then 4. 4 plus 4 plus 4 is 12, so you get the same answer. Same result. You like the first way better? Yeah, that was a little easier, huh? Okay, let's do another. Limit x approaches, let's go h goes to 0. H goes to 0. Square root of 4 plus h minus 2 over h. So what happens if I let h go to 0 here? You get 0 of 0, which is one of the bad scenarios, so we need to do some algebra, right? Do you see anything that we could do? Anyone? Anyone? Square root of 4, 8. Oh, the conjugate of the top. Why would you do that? So you want me to multiply the top and the bottom, I'm assuming, by the conjugate of the top? Why? Are you crazy or what? Because it's going to work. See, but you can't, I mean, someone has to show you that. It's not necessarily something naturally you would want to do, right? So let's see what's going to happen when we actually come in with the conjugate of the numerator, multiply it by on the top and bottom. Great things will happen. This is a bag of tricks, people, all right? I'm sharing And then apparently some of your classmates are also sharing the bag of tricks. So I'm stuck. I don't see a difference of squares. I don't see difference of cubes. I don't see a quadratic that I can try and factor. I see a square root. So square root, and I see two terms. So I'm thinking maybe conjugate. So I come in here and I multiply this by the conjugate. The conjugate is the same thing that appears, except you change the sign between them. So you make it a +2 instead of a -2. What you do to the top, you must do to the bottom. Why is that? Must do top and bottom. Because this is really a 1, right? You can multiply anything by 1 and it's still the same thing. So that's just to maintain the equality. So now what I have to do is I actually have to multiply this like a good old FOIL up across the top. Right? That means these two terms times these two terms. FOIL. On the bottom, I have to multiply h times these two, right? But h is the thing that's causing the problem, right? It's giving you the division by 0. So we always recommend do not multiply this through, just leave it. And you'll see on the next step, hopefully, what I mean by that. I'm carrying the limit with me. I'll write the bottom first, because I'm not going to do anything to the bottom. Just leaving it alone. So that's the h times both of these, which means it's in parentheses. Now let's do our FOIL up top. I hate FOIL to say FOIL, but expand it. What's root 4 plus h times root 4 plus h? 4 plus h. All right, what about the middle terms? They're going to cancel. That's why we do conjugate. So I'm not going to write them. Well, do you want me to write them? This times this times that. Those are gone, right? Take note. You know what? You tell me later if you need to see that step. What about the last two multiplied together? -4. How about that? Look at that. Look how nice this is. Because the 4 minus the 4, they're gone, which leaves you just the h on top and an h on the bottom, which now reduces out to be a 1, right? So what will my next line look like? Limit h goes to 0. What's on top? 1 is still up there. What's on the bottom? Square root 4 plus h plus 2. Right? Y'all saw that h went away, right? The h's only went away after the 4's were gone, right? Cannot cancel that h until those 4's are not there anymore. All right, now let h go to 0. What do you get? 1 over square root of 4, which is 2, plus 2. 2 plus 2 is 4. So 1/4? 1/4. If we were to graph that as a function, as we approach 0, it should be approaching 1/4. So when you see square roots, you should be thinking conjugate. It's usually pretty helpful. One more, okay? We're going to do one more. Y'all look exhausted. Maybe it's just me. Okay, limit h goes to 0. One over x plus h squared. But you know what? Let's take a vote before I do this one. Was the last one okay? Yes or no? All right, that's good enough. All right, so this next one would be considered medium difficulty, the one I'm going to put up, or would you like to see more difficult? So how many of you want to see this one? Say no if you want to see one that's probably like the peak of the level of difficulty. No is show me something a little harder. Yeah, no is 2. There you go. Don't do that to me. All right. That's good enough. All right, we'll go with something a little more challenging, all right? There you go. So there is a limit. And I want to know what's happening as h goes to 0. So just try plugging 0 in. You would get 1 over root x minus 1 over root x all over 0, wouldn't you? Which is going to be, yeah, when this h goes away, it's just 1 over root x. So, but 1 over root x minus 1 over root x is 0. So you get 0 over 0, don't you? Which is not good. So what we need then is algebra. And this will test our algebra a little bit here. We'll see how you can handle this. So I'm going to first realize that I have a complex fraction. It means a fraction within a fraction, right? These fractions are within a bigger fraction. And so I'm going to try and put these two together. To put these two together, what do I need? Common denominator. Which means I must introduce a root x on the top bottom on this one. And I need to introduce a what over here? Root x plus h on top and bottom here. Understand? If I do that, then what I can do is I can put those two together. Because they'd have the same denominator. So what would the new fraction become? And I'll give you a hint. It's all over h. Yes? So what does this new thing up here become? What's this top left right here? Root x over the common, right? Minus, what's this top up here? Root x plus h over the common. So all I really have to do is put this new numerator minus this new numerator over the common denominator. So I'll have root x minus root x plus h, but all of that over the common denominator, root x plus h. Those, the ones on the bottom are multiplied because it's the common denominator. The one on the top is subtracted because we put the two numerators together through subtraction. Tell me if that made sense or not, please. Yes or no? Now, if you check yourself, as h goes to 0 here, you would still get 0 over 0. So we're not done yet. In order for us to know that the limit's going to be okay, that we can actually take the limit, we need this h to go away eventually. We need to cancel it somewhere. So what now? What's that? H is over 1. Mm-hmm. Multiply what? I'm not sure I'm following. I heard h over 1. I heard multiply it. Oh, you want me to do this? You're saying rewrite that as h over 1 and then flip it up here? And then I can make it what over here instead? 1 over h, and then it wouldn't even be down here like this. Now, I'm going to bring all this back in because I don't want to do that yet. I agree I could do that algebraically, but have I solved the problem? Have I avoided division by 0 yet? No, because I still have division by 0 here, don't I? Yes? So I agree with you on the flipping, but I'm not ready to do it yet. We're getting there. Well, wait a minute, hold on. Just a second ago in the previous problem, you said you saw a square root and you were like, let's do the conjugate. And I said at the end of this, if you see square roots, you should be thinking conjugates, right? In this problem, we had square roots. Why didn't I do conjugates to begin with? Because they were separated fractions, right? I needed to bring them together into one term first. I'm considering this all one term. And now, do you see on the top I have two radicals and I have a conjugate of that, right? What is the conjugate of this? Root x plus root x plus h. I mean, could I do this algebraically? Is this legitimate for me to do this? Yes. Is it something you want to do necessarily? Probably not. But I could, and I can see what's going to happen, right? It's kind of like with these limits problems, when you get that situation of where it's bad, you've got to beat this thing to death with the algebra stick. I mean, until you get it to go. I mean, that's really what it is. And sometimes you try certain things and they don't work, but eventually you get comfortable to the point where you just, okay, that didn't work, let me try something else, with the overall goal of getting the H to cancel. But it's not like blindness. I mean, you're not just kind of swinging blindly at it. I mean, you are thinking, okay, conjugate because I see radicals. If I see difference of cubes, I'm thinking factor difference of cubes. I mean, so there's thought to it, but you still have to be willing to fail and try something else. So I'm hoping that's going to work out. What is my numerator? Okay, so do my little expanding out here. We said when you do this, the middle terms aren't going to matter, right? So what am I going to get here? Root x is going to give me x. Then the outer ones, when I multiply these two, be extremely careful here. Tell me what I'd get. You get negative, because you have a negative times a positive, and then x plus h, but in parentheses, the x plus h. Because root x plus h times root x plus h is x plus h, but you are subtracting it because it's positive times a negative. When you subtract a binomial, you have to distribute the negative through both. So that's why I've left this in parentheses. All of that is over what? This denominator, right? This one right here, which sucks. It's these two multiplied times this. And I'm going to just leave it like that. Not even going to try and clean it up. X plus 4. But this whole thing is divided by what? H. I'm hoping for that H to cancel. Is it going to? Yes, because what is this right here? That's x minus h minus x minus x minus h, isn't it? And the x's go away, which leaves me with a negative h on top. So this right here is a negative h. That negative h will cancel with this h. So I'll be left with a negative 1, though, because it was a negative h. So this going away, I'll write it out. I have limit, h goes to 0. Tell me again what's on top. Negative 1 is on top. And on the bottom, just root x plus h. Then parentheses root x plus h. Close that off. The h on the bottom went away, right? So that canceled with the one up there. And now, because that h canceled, I'm willing to take a shot at this and let h go to 0 and hope for the best. So what happens when I let h go to 0? So no more limit, negative 1 over square root of x times, this h went to 0, so square root of x again. Then in parentheses, square root of x plus what? Square root of x. All right, what's root x times root x? X. What's root x plus root x? 2 root x. So how about I write it like this? I just put the 2 out front. This right here is 2 root x times x, so that's 2x times root x. And box it up. This is it. That one was a little more challenging, I guess. Okay, so what I think you should do for your homework, let's see. I'll give you your homework assignment right now. I think you need to look at, off of page 44, you need to look at 11 through 27 odds. I did some of the evens. If you want, you finish the odds, go do the evens too if you want. And then that was from 1.4. From 1.3, let me see if there's anything I think you should do. Page 33. Three, 5, 7 through 10. That's good. All right, make sure you turn your clickers in over there. All right. I plan on having a quiz on Thursday, but just probably one quick limit problem where you have to do some algebra. It won't be like this one. It'll be much more basic just to make sure you understand the concept, all right? Something like the homework.